of w equals to r. Now we are also given that argument of z and argument of theta equal or w equals to pi. So that is theta plus phi equals to pi. So we can write theta is equals to pi minus phi. So z will be equals to r e to the power I in place of theta, that is pi minus phi. So it will be r e to the power I pi into e to the power minus I phi. Now we know that e to the power I theta is cos theta plus I sin theta. Are you all comfortable with this Euler form? Cool. So e to the power I theta is cos theta plus I sin theta. So e to the power I pi will be cos pi plus I sin pi, that will be minus 1. So this will be minus r and e to the power minus I phi. So we can note that e to the power minus I phi will be equals to cos minus phi plus I sin minus phi. And we know that cos minus theta is cos theta. So cos minus phi is cos phi and minus I sin phi. So we can here see that this will be equals to, if cos phi plus I sin phi was into r was, this quantity will give us omega if we are having, or w we are having r cos theta plus I sin theta, then omega w conjugate is r cos theta minus I sin theta. Oh, sorry, phi we are using na. Okay, so we are getting that value here. So this value is minus of omega conjugate or w conjugate. So we are having this option B. So B is our correct option. Clear? Now moving to the next question. We are given mod of z minus 4 is less than modulus of z minus 2. Then its solution is given by. So to solve it, you are having two different ways. First is, what you can do is you can take z equals to x plus iy. Then z minus 4 modulus is mod of z minus 4 plus iy, and mod z minus 4 square will be, similarly mod of z minus 2 will be x minus 2 plus iy, which will lead to mod z minus 2 square is x minus 2 square plus y square. So you would be getting mod z minus 4 minus 2. So we will be having on squaring these two. We will be getting x minus 4 whole square plus y square is less than x minus 2 whole square plus y square. On solving, you will be getting x square plus 16 minus 8x plus y square less than x square plus 4 minus 4x plus y square. This will get cancelled out, this will get cancelled out. We will be getting 16 minus 4 less than 8x minus 4x, so 12 less than 4x. So x will be greater than 3. So we can see that the real part of z will be greater than 3. So the correct option is answer C. Now in this question, you can solve it in a different manner like this, that you can see here. We know that if we are having an Argand plane in which this is a real axis, this is an imaginary axis, and we are having two points P and Q which are represented by the two complex numbers Z1 and Z2, then this length of PQ is given by mod of Z1 minus Z2. Now here, what we are having is, we are having 2 points Z minus, in place of Z1 we are having 4 plus 0 I cap, oh sorry I, and in place of Z2 we are having this 2 plus 0 I. So we are having this point 2 comma 0 and we are having this point 4 comma 0. Now Z is such that its distance from Z minus 4 will represent distance from B, and distance from A is represented by Z minus 2 modulus. Now it is given that the distance from Z minus 4, we can see that if these two distances are equal, Z minus 4 distance equals to Z minus 2, this implies that Z will lie on bisector of AB, because the distances will be always equal. But now the distance from Z minus 4 means distance from this point B is less than distance from 2, or we can say that distance from B is A is more, so this point lies on this region. And for this region, we know that this is the midpoint 3 comma 0, so in this region the real part of Z will be greater than 3. Both the methods clear? So let's move to the next question. Our next question is, the locus of the center of the circle which touches these two circles. So we are given the equation of two circles. That is modulus Z minus Z1 equals to A and modulus Z minus Z2 equals to B. And it is given that it is touching both the circles externally, where Z, Z1, Z2 are all complex numbers. So we need to find the locus of the center of that circle. So we can say that this is one circle and this is our another circle, and this is the circle which is touching both the circles externally. Let's say center is Z0 and this point is Z1, this is Z2. So we will try to find the distance between, let's say, A, B and O. So the distance of AO will be given by mod of Z0 minus Z1 equals to, let's say its radius is R and R, here it is A and B. So this value will be equals to R plus A. And similarly, the value of OB will be mod of Z0 minus Z2. This value will be equals to R plus B. Now here, we are having a variable R. We have to eliminate it. So what we can do here is we can subtract the two equations. So we will be getting, from subtracting equation 1 with equation 2, mod of Z0 minus Z1 minus mod of Z0 minus Z2 is equals to A minus B. Now here, Z0 is our point and the distance is fixed because A and B are given in the question. So can anybody tell me what is the locus of a point which moves such that the difference of its distance from the two fixed points is constant. Here we can say that we are having the two fixed points z1 and z2 and the difference is constant. So the correct answer is hyperbola, the locus of a point which moves such that the difference of its distance from the two fixed points is constant is hyperbola. And what is the locus of a point which moves such that the sum of its distances from the two fixed point is constant? Ellipse. So if this question is molded in the form that if this would be touching it internally, then we would be getting r minus a, r minus b, then also we will be have subtracted only. Okay. So let's move to our next question. We are given 1 plus I upon 1 minus I whole to the power x is equals to 1. So what we are going to do is 1 plus I upon 1 minus I. Let's simplify this. Multiply and divide by 1 plus I. So in numerator we will be getting 1 plus I whole square upon 1 square plus, or we can say minus I square. So 1 plus I square plus 2I upon 2. This will get cancelled out as I square is minus 1. So 2I by 2 we will be getting I here. So I to the power x is 1. So from here we can see that x should be 4 into n. So our correct option is 4n. Yeah. Ayushi, this is in NCRT. Now let's solve this question. Do you want me to give some 20-30 seconds for each question? Okay, let's do it like that way. So giving you 30 seconds for this question. Okay. Okay. So what we are given is Z and W are the complex number. Let's say omega, we are saying this is not the cube root of unity. With a complex number such that Z conjugate plus I into omega conjugate equals to 0 and argument of Z into omega is pi. Then argument of Z equals to. So we are having Z conjugate plus I omega conjugate equals to 0. If we will take conjugate all the sides, so this will be Z plus I conjugate into omega I conjugate will be I only, or that will lead to minus I, sorry. So I conjugate and omega conjugate of conjugate will be omega equals to 0. So Z I conjugate minus I omega equals to 0. From this we will be getting omega equals to Z upon I. Now we are also given that the argument of Z into omega is pi. So the argument of Z omega is Z upon I. So this we can be getting argument of Z square minus argument of I equals to pi. So we know that this will be 2 times of argument of Z minus argument of I will be pi by 2 equals to pi. So 2 times of argument of Z equals to pi plus pi by 2, that will be 3 pi by 2. So argument of z will come out to be 3 pi by 4. Yeah, the correct answer is C. See, we are having the properties for argument, that is argument of z1 into z2 is equals to argument of z1 plus argument of z2. Make sure it lies in the region of minus pi to plus pi. And argument of z1 by z2 is argument of z1 minus argument of z2, and argument of z to the power n is n times the argument of z. Let's move to the next question. These are things are clear, right? If you are going for the first quadrant, second quadrant, third quadrant, or fourth quadrant, what you need to do for the argument, what basically you can do is, if you are having any of the four quadrants, then first, if you are having z equals to x plus iy, then find tan alpha. This tan alpha is mod y upon mod x, or y upon x whole to the power whole mod. That is taking the positive value. Now, if you are in the first quadrant, then this alpha will be equals to theta. If you are in the second quadrant, then this will be alpha, but our theta is our argument, that will be pi minus alpha. And if you are in the third quadrant, then this will be alpha, because this point will be x comma y. This point will be x comma y. This will be minus x comma y. This will be minus x comma minus y, but you have to take from here. So the argument, that is theta, will be equals to, and we are going in the clockwise direction. So when you are moving in the clockwise direction, then you take the argument to be negative. So that is alpha minus pi. And if you are even in the fourth quadrant, then this is x comma minus y. In this case, this will be alpha, but our theta will be equals to minus of alpha. Clear? So this is how you can find the argument in all the cases. Moving to the next question. If we are having z equals to x minus iy, and z to the power 1 by 3 is p plus iq, then we need to find this value. Giving you 20-second time. It is a very easy question. Okay, so from here we can see that z to the power 1 by 3 is p plus iq. So z will be equals to p plus iq whole cube. From here we can see that z will be equals to a cube plus b cube plus 3a square b plus 3a b square. Then we would be getting the real part will be p cube minus 3pq square plus I, and that will be 3p square q minus q cube. Now z is equals to x minus, or we can take out the minus sign here, so this will come out to be q cube minus 3pq square. Now on comparing, we would be getting the value of x equals to this. So x is equals to p cube minus 3pq square. So x upon p is our p square minus 3q square. And equating the imaginary part, y will be equals to q cube minus 3pq square. This is p square cube. Okay, sorry. So y upon q will be equals to q square minus 3p square. So on adding these two, we would be getting x upon p plus y upon q is minus of 2 times of p square plus q square. So x upon p plus y upon q upon p square plus q square equals to minus 2. So the correct option is B. Good. Moving to the next question. We are given mod of z square minus 1 is equals to mod z square plus 1. Then z lies on. So we know that if we are having mod of z square, then we can write mod z square equals to z into z conjugate. This helps us to find the solutions very easily. Now we are having z square minus 1 modulus equals to mod z square plus 1. So squaring both sides. Now this is a complex number, but this is not a complex number. This is a real number. So we can apply the direct formula for the squaring. And here we can write it as z square minus 1 into z conjugate square minus 1 z into z conjugate. So you can write this as like this, and it will be equals to z to the power 4 and 1 plus 2 mod z square. Now we know the properties of modulus. If we are having two complex numbers z1 and z2, then this conjugate is equals to z1 conjugate into z2 conjugate. Similarly, z1 plus z2 whole conjugate is z1 conjugate plus z2 conjugate. Here we will be getting the conjugate for the z square. Now on multiplying, we will be getting z square into z conjugate square minus this minus z square plus 1. So z into z conjugate will be mod of z. So on solving it, this quantity will get cancelled out. One and one will also get cancelled out. So what we are having here is this power 4. This will get cancelled out. Taking these terms aside, so we are having mod z square, a z square plus z conjugate square plus 2 mod of z. We can write it as z into z conjugate equals to 0. So from this we are getting z plus z conjugate whole square equals to 0. So z plus z conjugate equals to 0. So z plus z conjugate is equals to 0. This implies that the real part will be 0 because z will be x plus iy. So we are getting x plus iy plus x minus iy equals to 0. This implies x equals to 0. So x is our real part. So if real part is 0, then z will lie on the imaginary axis. Moving to the next question. Our next question is, if the cube roots of unity are one omega and omega square, then the roots of the given equation are. So this equation we can write it as x minus 1 whole cube is equals to minus 8. We can write it as x minus 1 whole cube equals to minus of 2 whole cube into, or we can write it as 2 cube and let's say minus 2 and 1 cube. So x minus 1 will be minus 2 into 1 to the power 1 by 3. So this will give us the cube root of unity. So x minus 1, we know the cube roots of unity are either 1 or omega square. So from this, putting the three different values, we will be getting x minus 1 equals to minus 2, or x minus 1 equals to minus 2 omega, or x minus 1 equals to minus 2 omega square. On solving this, we will be getting x equals to minus 1 and x equals to 1 minus 2 omega and x is equals to 1 minus 2 omega square. Clear? There is some misprinting, so the correct option is we will get only three roots. So obviously this is the misprinting. So our correct option is C. Moving to the next question. Is it clear this one? Solve this one. I'm giving you 30-second time. Now, we are given Z1 and Z2 are two non-zero complex numbers such that modulus of Z1 plus Z2 is equals to mod of Z1 plus mod of Z2. We know that mod Z1 plus Z2 whole square is equals to mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2 into cos phi, where phi is equals to argument of Z1 minus argument of Z2. Now it is given that mod Z1 plus Z2 whole square will be equals to mod Z1 plus mod Z2 ka whole square. So we would be having mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2 cos phi is equals to square. Using the formula of square this side, we will be getting mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2. On comparing, we are getting cos phi equals to 1. So this implies that phi is equals to 0. Since phi is 0 in here, so phi is our argument of Z1 minus argument of Z2. So this comes out to be 0. So our correct option is answer C. Is it clear? Moving to the next one. The next question is omega is equals to z upon z minus 1 by 3i, and it is given that mod of omega equals to 1. Then z lies on. Again giving you 30-second time. Okay, so anyone giving answer? Now you can see that modulus of w equals to 1, that is modulus of z upon z minus 1 by 3 I equals to 1. How to solve it? You will have two methods, that is z equals to mod z minus 1 by 3I. So we can see that we are having this is z minus 0, so we are having this orthogonal plane then which this point is 0, and we are having a point comparing it with the z minus z naught. In the first one, z naught is in the LHS 0 plus 0I, and in the RHS part, z naught is r 0 plus 1 by 3I. So this is point, and the other point is 0 comma 1 by 3. This is our real axis, this is our imaginary axis. So it is given that a number or a point lies such that the complex number representing it is at equidistant from the point origin and this point A. So obviously that point will lie on the perpendicular bisector because these two distances will be same always. So we can say that then Z will lie on the perpendicular bisector of line joining this 0 comma 0 and 0 comma 1 by 3. So it is not an ellipse, not a circle, it is not a parabola, it is a straight line. Is it clear? This is one method. The other method we can use is, if you are not cool with this one, what you can do is, let's say z is equals to x plus iy, then mod z is under the root x square plus y square, and mod of z minus 1 by 3I will be under the root x square plus y minus 1 by 3 whole square. So equating these two, we will be getting under the root x square plus y square equals to under the root x square plus y minus 1 by 3 whole square. Squaring both the side, the root will get cancelled out. And now on simplifying, we would be getting x square plus y square plus 1 by 9 minus 2 by 3y. So we will be getting 1 by 9 equals to 2 by 3y. So y equals to 1 by 6. And y equals to 1 by 6 represents a straight line which passes through this point 0 comma 1 by 6. That was the midpoint of our 0 comma 0 and 0 comma 1 by 3. So the midpoint was 0 comma 1 by 6. So we are getting the same answer here also. Okay. Clear with both the methods? This represents a straight line. I'm moving to the next question. I'm giving you again 30-second time. No, this one answer is not B. Okay, Parth, what we are going to do here is, we can see here that if we are having 1 to the power 1 by n, that is nth root of unity, then we can write it as cos. See this, you can write it as 1 is cos 2k pi plus I sine 2k pi to the power 1 by n. So this will be equals to cos 2k pi by n plus I sine 2k pi by n. So what we are having here is 1 to the power 1 by n can be written in this form. Okay, so but it is not in the form of cos theta plus I sine theta. It is in the form of sine theta plus I cos theta. So how can we make it in that form? We are taking this I common. Oh, so sine theta sine 2k pi by 11 plus I cos 2k pi by 11. We are having. Okay, so what we can do here is let's go minus 1. So what we are having here is we can multiply it by or take this as minus 1. We can write minus 1 square. We can write, or we can write it as minus of I square and take this I common. So you would be getting cos 2k pi by 11 minus I sine 2k pi by 11. Now if you're writing it in this way, then if you are having the roots, you will be getting the conjugate of the roots. Okay, so if we are saying that alpha square, see all the roots are in the power only, no? So this is I into e to the power 2k pi by 11. So if one root we are getting from putting k equals to 0, then 1, then 2, then 3, so on up to 11, so on up to 10. From k equals to 0 to k equals to 10, if you will put, then you will get the different roots. So on putting k equals to 0, we will be getting 1, so minus. So what we are doing here is, let's say if 1 alpha square, so on up to alpha to the power 10 are roots of, or we can say that are 11th roots of unity. So this quantity what we are getting is, if you are putting this summation k equals to 1, then you will be getting 1 by alpha, because you will be getting this is minus, so alpha will be cos 2 pi by 11 plus I sine 2 pi by 11. So 1 upon alpha will be its conjugate, cos 2 pi by 11 minus I sine 2 pi by 11. How you can say that is, alpha is equals to e to the power I theta, then 1 upon alpha will be 1 upon e to the power I theta, that is e to the power minus I theta, and e to the power minus I theta represents cos theta minus I sine theta, so 1 upon alpha is the conjugate of 1. Okay, so we are getting this 1 upon alpha, then the other one will be 1 upon alpha square, because we are having the summation sign in here. So the next will be 1 upon alpha cube and so on up to 1 upon alpha to the power 10. Now, if you'll solve this, you will be getting I into alpha plus alpha square plus so on up to alpha to the power 10, and on multiplying all these terms, you will be getting alpha into alpha to the power 10, that will be again 1, alpha square into alpha to the power 9, again 1. So you will be getting all 1 here. Now for this, what we are going to do is, we know that these are the 11th roots, so x to the power 11 minus 1 equals to 0. So we are having the 11 roots 1 plus sum of roots alpha square plus so on up to alpha to the power 10 will be 0 from the formula minus b upon a. So this whole quantity alpha plus alpha square plus so on up to alpha to the power 10 will be equals to minus 1. Putting this equals to minus 1, so we'll be getting the answer minus I. So the correct option is D. Got it? See, we are using the concept of nth root of unity in here. Arushi and Kavita. Moving to the next question. So our next question is, if z square plus z plus 1 equals to 0 and z is a complex number, then the value of z plus 1 by z, I guess this is, okay, I'm rewriting it whole. This is z plus 1 by z whole square plus z square plus 1 by z square plus z cube plus 1 upon z cube plus z to the power 6 plus 1 upon z to the power 6 whole square. Okay. Try it. It is a very simple question. Okay, 30-second time. Okay, so we are having z square plus z plus 1 equals to 0 and z is a complex number. So from here we know that this equation gives us either z equals to omega, that is cube root of unities, we will be getting omega or omega square. So let's say z is our omega, then 1 upon z will be 1 upon omega and 1 is omega cube, so it is omega square. So z plus 1 upon z will be omega plus 1 up, omega plus omega square, and we know the property of two roots of unity, that is 1 plus omega square equals to 0. So omega plus omega square is minus 1. So the first term we are getting is this, so its whole square will be minus 1 square. Now z square will be omega square and omega square whole square will be omega, because omega to the power 4 we can write it as omega cube into omega, that will give us omega only. This is again minus 1 square. Now omega cube, we know that it is 1, so it is 1 plus 1. So we would be getting 2 to the power 2, that is 4, and z to the power 6 will be again 1, so that will be again 4. So what we are having is 1 plus 1 plus 4 plus 4. As this series z cube, then it is going from 4 plus 5 plus 6. It should be like this only. Now we are having this value 1, this value was also 1, and this value was 2 square, that is 4, and this value we are getting is the omega to the power 4, that is 2, oh sorry 1, and this is 1, and this is again 4. So what we are having answer is D, answer is 12. Clear? Moving to the next question. If A and B denote the statements, A is cos alpha plus cos beta plus cos gamma equals to 0, and B is sin alpha plus sin beta plus sin gamma equals to 0, and cos beta minus alpha plus cos gamma minus alpha plus cos alpha minus beta is equals to minus 3 by 2, then let's put 2 in here. So we will be getting okay, 2 cos beta minus gamma plus 2 cos gamma minus alpha plus 2 cos alpha minus beta equals to minus 3. Taking minus 3 this side, plus 3 equals to 0. Now this is 3 plus 2, and this will be cos A minus B, that is cos A cos B plus sin A sin B. Multiplying this 2 with both the terms. Similarly, this will be cos sin gamma sin alpha plus 2 cos alpha cos beta plus 2 sin alpha sin beta. Now we can write this 3 as 1 plus 1 plus 1, and 1 will be cos square alpha plus sin square alpha cos square beta plus sin square beta and cos square gamma plus sin square gamma. So we will be getting sin cos square alpha plus cos square beta plus cos square gamma plus 2 cos alpha cos beta plus 2 cos beta cos gamma plus 2 cos gamma cos alpha plus sin square alpha plus sin square beta plus sin square gamma plus 2 sin alpha sin beta plus 2 sin beta sin gamma plus 2 sin gamma sin alpha equals to 0. From this, we can see that this is the formula of a square and this is also square. So we are having cos alpha plus cos beta plus cos gamma whole square plus sin alpha plus sin beta plus sin gamma whole square equals to 0. So both are correct statements, because if the sum of two squares is 0, then both the values should be 0. Then only you can add up to get the value 0. Got it? Moving to the next one. We are given alpha and beta be real with 30-second time. So we are given alpha and beta be real and z be a complex number. If z square plus alpha z plus beta equals to 0 has two distinct roots on the line whose real part is 1, then it is necessary that. So we can say that if we are having the two roots, let's say the roots are m and n, and they both will be the complex roots. So if the roots are complex, then if m is 1 plus something, say ki, then n will be 1 minus ki. We know that both the complex roots are conjugate of each other, and it is given that the roots lie on a line whose real part is 1. So we are taken the real part as 1. Now, for the condition on beta only we need, so alpha, we can directly say that alpha will be equals to sum of roots, that is true. Now for beta, taking the product of roots, the product of roots m into n will be equals to beta. So beta will be equals to 1 plus ki into 1 minus ki. So beta will be equals to 1 square plus k square. So obviously beta will be greater than 1. So this implies that beta belongs to 1 to infinity. So our correct option is option B. Got it? Now moving to the next question, I guess that would be the last question of day. The common roots of these two equations are. So from the first equation, we can see that having z cube plus 2z square, that is z square plus z square plus z plus z plus 1. So that would be z square z plus 1. This would be z plus 1, and this will be plus 1 z plus 1 equals to 0. So we would be getting this plus this equals to 0. Now from here we are getting either is equals to minus 1 or it is equals to omega and omega square. So the three roots are minus 1, omega, omega square. Let's check it for the second equation because the two roots should be common. Putting is equals to minus 1, we would be getting minus 1 to the power 1985, that is an odd number, will give us minus 1 to the power even number will give us a plus 1 plus 1. This quantity is not 0, so z equals to minus 1 does not satisfy. Now z equals to omega. So here we are getting omega to the power 1985, and it's just divisible. This is not 1 plus 995, 5 we are having, so 3. This will be omega square, because if you'll add all these and you will be getting 1 plus 9 plus 8 plus 5, so 5 3 plus 2, this will get divisible by 2, you will be left with omega square. Similarly, you will be getting omega in here plus 1, and we know that omega square plus 1 equals to 0, so it's equals to omega is satisfying it. Now checking for the next is omega square. So again, this will be omega, this will be omega square plus 1. Obviously, this is 0. So the correct answer we are getting here is A. Clear? So thank you guys. That was for all today.